So in the last video we looked at how to instantiate objects in the C# scripts. Now we're going to expand on that because the only object that got instantiated was the particle system for when the player character gets destroyed. We're going to expand on that substantially, and it's going to get back to what I said in the original video about optimization and about having objects be brought into the scene as needed rather than too soon, at the very beginning when the scene loads and now you're loading all the assets that aren't needed. It might bog down the system. So first thing I'm going to do is we're going to take the gate, so the exit, and let's just move it out. Way out. Since that's out of the way, you can delete a whole bunch of these. We want to avoid, we don't want to delete the coin, but the other stuff can be deleted. Okay. So what we're going to do is we're going to grab two sets of columns, so two sets, plus two sets of blocks. So that's 10 blocks and 2 columns. And we're going to turn it into a prefab. So we're going to link those objects together, and then we turn it to a prefab, and at that point it can be instantiated. So just as we instantiated the particle system, we can instantiate that collection of objects, and we can assemble the world in real time. So let's highlight these and see how many I can just randomly grab. That's absolutely perfect. So what we want to do, so from cube 30 down to cube 33, we want the middle cube on the left one to be the center. So let's see, cube M, cube. Yep, it's that one. So let's just move this in the list just so it's easier to track. Alright, so we said that cube 30 through, what's the cylinder, 33, cube 33, there we go. So, all those, we're just going to drag and drop and place it on top of cube M. So these have all now been set as children, and the cube M is the parent. So whatever you do with cube M, everything else follows. So if cube M gets instantiated, everything else gets instantiated. If it gets deleted, everything else gets deleted. If it gets moved, rotated, whatever. So just move this to make sure, double check that it's correct. Now, you might be saying, well, why did you use 2 sets? Why not just 1 set? And having 2 sets does a couple things. A, you have to instantiate less, which isn't that big of a deal because you can set up routines to instantiate over and over again, so it really doesn't save any effort there. But the bigger one is that once you start instantiating pieces, that means you can randomize as well, because you can put in randomized statements. And so I'm protecting against a situation where a pattern is created that is unusable by giving you that extra set. So once we get a little deeper into it, it'll probably make more sense. So let's take this and drag and drop it into our asset area, and it is now a prefab. So we can delete the original, and we can go ahead and delete these remainders as well. Okay, so now what we're going to do is we're going to have GM handle the instantiation. So let's go into the GM object, or the GM script, excuse me. zoom in a little bit. And what we're going to do is going to add a transform type of object. So public transform, capital T, and we'll call this we'll call it BB for building block, and then we'll say no pit, because it does not have the pit in it, as in over here somewhere. There's the hole that can be dropped into right there. So now what we're going to do, we'll create another one which does have the pit. And there's a couple ways we can do this. What we can do is we can take that one that we just created, bring it back in, okay, delete the corresponding block that we want, we'll delete that, and so now this one has a pit in the middle. So we take this, drag and drop it, and we're going to just rename this. So we'll delete that again, and let's name this block pit mid, because the pit is in the middle. And this one we'll just call this block no pit. Public transform BB pit mid. Now we'll go back to the GM object, and there they are. So now block no pit goes to the top, and block with a pit in the middle will go there. So I'm going to actually write this out a couple times. So forewarned, I'm going to put in a few lines and then we'll wind up deleting it just so you get the sense of how it works. So we want it to be done in the start section, unless you're looking if you're looking at something much further down the track than that, you'd actually want to set a timer for, because like we said, part of the reason for this is optimization. So you don't want it necessarily to show up in the start unless you need to access it at the very beginning. So for now we'll deal with this because this is visible from the beginning. So instantiate. So what needs to be instantiated? We'll start with BB no pit. So that's what gets instantiated, where it gets instantiated. New vector 3, and then we have to put in the x, y, and z coordinates. Just do this for the moment. And then the rotation. So we want to use BB no pits dot rotation. Now let's take a look at where it was originally. So no pit was originally 0, 2.17, and 42. So 0, 2.17 F, comma 42. Now since this is 2 units deep, then rather than skipping by 2 when we're doing it manually, would be skipping 4 because it's 2 blocks deep. Now what we'll do is we'll copy this, And like I said, we'll put it at 46. Put this one at 50 and this one at 54, but we want it to be BB, sorry, it's the third one I want, BB pit mid, BB pit mid, and BB pit mid's rotation. And we'll save this, and if I didn't make any mistakes, even though they're not here, they'll get drawn in at the start. And sure enough, you can see them up there in the distance. So those you'd want in the start section, but if you get too much further, then that's when you're going to want to start optimization. And this is what I was talking about. You want that second block in depth, that way you don't accidentally create areas that can't be traversed. You can do other things to prevent that from being an issue, but that's a very easy one. So now what you can do is you can create a routine to make this happen over and over again. Now, because of the pit being a different one from the block, this isn't a great contender. But say beyond the pits, we want a whole bunch more. So we'll grab one of these and put it here. We're going to create a new variable, public, and it's going to be int. Actually, we'll make it a float since it's a coordinate. Public float z, we'll call it z scene POS, because usually when I do z or x or y POS, it's usually specifically for a player character. So I'm very specifically addressing this as a z scene position. And it will start off, let's see, if this goes up to 54, then that means 58 would be the next one. So it starts at 58. Okay. There's a bunch of different ways to do loops. I'm just going to use an if statement since it's something we're all familiar with, because we've already used them in this project. So if z scene POS is less than, say, 120. Then we want to instantiate that at z scene POS, and with every pass, z scene POS will be increased by 4, because we said that's the amount that needs to be incremented by, because it's 2 blocks deep. And this, so 1, 2, 3 lines, is going to draw dozens of these. So actually this won't work like this because it's in the start area. Let's drop into the update area. So going to be drawing it as you're approaching it, but should be far enough away to not be an issue. There we go, I can see them already. Okay, see how it's that deep now? So now, with just those 3 lines of code, you made this huge corridor, and now you can just start dragging and dropping, or instantiating, either way, the pits as well as the obstacles and the power-ups. So yeah, so just 1, 2, 3 lines of code, and like I said, you just place dozens of those. Now that works out good for things that are going to be repeated. If it's not being repeated, then it's going to be messier. It's going to be like that. But still, it allows you to load things as needed. And the second half of that is, as you load things that are needed, you can then destroy things that are no longer needed. We can deal with that later. I don't foresee this being really that resource intensive of a project, but once we start adding textures and other things, it could be. So one possibility is you could have some kind of collider box back here that is very slowly moving, and just as it collides with things, it destroys them. So you could do all kinds of things like that to get rid of resources that you don't need anymore.